हॅलो पारेकर सर.
हा मावळे सर.
हा सर.
हा बोला ना सर.
थांबायचं आणखी.
एक 2-3 मिनिटं थांबू.
चालेल चालेल ठीक. ओके ओके.
हा चालेल चालेल. Good morning. Today we have a session on ferrocement applications. Speaker actually we have Chandramohan Hangekar sir, but because of some problem he is not available. So he sent us a video and we are going to tune that video that is about for 1 hour. And if you have any questions answers, then Modak sir will give you email ID or you can post your questions on ferrocement@gmail.com also. Now I will request Modak sir to introduce Hangekar sir.
Thank
Modak
you, sir. Thank you, sir. I am very glad to introduce Engineer Chandramohan Hangekar, sir, who is the speaker for today's webinar. He graduated from CUEP with a gold medal for his bachelor's degree. He worked as Chief Engineer in Water Resources Department of Government of Maharashtra. He has a vast experience of working in the field. He is a fellow member of various professional bodies like IEI, IGS, IWRS, to name the few. He is presently working as the president of Ferrocement Society of India. He is in the committee of Ferrocement Handbook of Government of Maharashtra. Apart from being the master of technical field, he is also a good
हा सर तुम्ही म्यूट झालेत मोडक सर.
musician. I'm sure all the
मोडक सर तुमचा आवाज नाही येत आहे. मोडक सर
हाँ सर
आवाज
Yes, sir.
नाही येत आहे तुमचा. हा
काहीच नाही आलं.
हा आता आला आला आलाय बोला.
Okay, I'll give his brief introduction for engineer Chandra.
सर आवाज जातोय तुमचा परत. मोडक सर मोडक सर
IGS IWRS to name the few. He is presently working as the president of Ferrocement Society of India. He is in the committee of Ferrocement Handbook of Government of Maharashtra. Apart from being the master of technical field, he is also a good musician and a writer. I am sure all the participants will have great number of takeaways from today's webinar. Thank you. I'll share his mail ID in the chat box so that you can ask if you have any queries regarding the webinar. Thank you. Sir, Parikar sir.
हा चालेल. नाउ आय विल स्टार्ट व्हिडिओ प्लीज.
Hi friends, on behalf of your college, your institute and Ferrocement Society of India, I welcome you for this online webinar on ferrocement applications. Ferrocement, as you know, is a magical technology, and this is the most convenient construction method, just like RCC. You must have seen the RCC construction, the framework, columns, beams, slabs for many buildings or infrastructure projects. But this technology, which is called as ferrocement technology, is slightly different from the concrete technology. And today I would like to take you to the magical world of ferrocement. So are you prepared? Yes, you are prepared. So let's see how the world looks towards the ferrocement. All over the world, people are using ferrocement technology. So we will just look what is ferrocement, how it is applied in different construction methods and construction infrastructure projects, building projects like that. So let us go ahead. As you know, there is International Ferrocement Society, which works all over the world, and every third year they are organizing international conferences. Ferro 13 is proposed in July 2021 in France. So we are going to attend it. Last conference was in 2018, that was in Brazil. Our members attended that. We, along with me, attended the conference in Aachen, that is in Germany. In India also, in 2024, we are planning to host this international conference. So let us see how it is possible. In India, we normally organize the national conferences. Nomenclature of these conventions is FS 2011, FS 2013, and like that. Last year, in 2019 only, we have organized FS 2019, and next is planned in FS, that is FS 2021 next year. Ferrocement, rather than material, it is called as a ferrocement technology, just like RCC technology. It has got certain method how to make the ferrocement components, or how to build or construct the ferrocement infrastructure or building projects. This is the most popular technology in architects and engineers because of its curved shapes possibilities. Many curved shapes are possible only with ferrocement. It is possible with RCC also, but the formwork and centering costs more in RCC. We opt for the ferrocement because of the possibility or ease with which we can construct the curved shapes. Dr. B.N. Divekar has developed a methodology for designing ferrocement structures, and he has written a book on ferrocement construction manual also and design of ferrocement also. These books are available with the Ferrocement Society. You can refer to that. Now, this is the very popular structure which is built in Mexico City, which is called as a Nautilus house. This is a very attractive structure, as you see, very colorful, and the shape what we see here is called as the organic shape. This is the irregular shape, or it matches the natural shapes. That's why it's called as the organic shape. This is the interior of that building. The building is called as Nautilus house. See the interior, the curved walls or the curved furnitures, the curved cupboards, beds, roofs, all these are constructed using ferrocement technology. This is the sit out in that building, Nautilus house. Looks very nice. And this is in Japan, the curved roof or the cylindrical shape house. And this is a very peculiar building built in New York. This is called as a duck house. Actually, originally this building is built using ferrocement technology, and that is in 1931. The building was bodily shifted from one place to other place. It was installed on a trailer and it was moved through the roads or highways. So this is the building. The walls of this building, duck house, they are hardly 50 millimeter thick. So you see how the shape is built. So this is the beauty of ferrocement technology. You can have curved shapes very easily. And such types of buildings are called as the aerodynamic shaped buildings. As you know, tsunamis or cyclones, they have got very large velocity, and that's why in order to resist the wind pressure or to allow the wind to flow above the building without exerting the pressure on the building, we need some curved shapes, or which are called as the aerodynamic shapes. You know, cars, previously the cars were having vertical glass in front of the driver. So that type of glass, while we drive the car, the pressure is exerted on that glass. So nowadays the glasses of the car are very sloping, and that's why the wind pressure exerted is minimized. So that is the thing why buildings also on the seashore, the wind pressure is very high. And in case of cyclones, or just like you had seen few days ago, Nisarg, that was the cyclone, typical cyclone, and the speed was 120, 125 kilometers per hour. it hit at the Konkan area or Mumbai area. So in Bali, Indonesia, these countries, they are facing hurricanes and wind speed 480 kilometer per hour. So that type of heavy winds or heavy pressure that is exerted, that pressure is exerted on the buildings, and that's why aerodynamic shapes are very popular in such countries. So these aerodynamic shapes are quite possible using ferrocement technology, because curved construction is very much easy in using the ferrocement technology, as you know. You see the another slide, the curves are there and the finishing is also very good. These are called the anti-tsunami homes in Japan, Chile, Indonesia. These are popular. You see the Mexico homes, they are also having some spherical, half spherical shapes. Basically, now you see a canteen building in Osaka. See the thickness of these canopies. You will see all these are constructed with the help of ferrocement, and in ferrocement, as you see, 30 millimeter, 40 millimeter, or at the max 50 millimeter thickness is quite sufficient to bear all these loads, because this is a thin construction. So that's why this ferrocement technology is very popular. How to construct and how are the components mixed? I request Dr. Divekar sir to continue with the ferrocement construction, how these meshes are tied up, how this mortar is prepared, and how this mortar is filled in this component to make the ferrocement plate or ferrocement component. Dr. Divekar.
स्टील बार वेल्ड केले हे 6 mm ते 8 mm डायमीटरचे बार असतात. मोठा बार वापरायचा नाही, कारण आपला मुळातच थिकनेस 30 ते 40 mm असतो. त्याच्यात 10 mm त्या 12 mm बार वापरलं तर तेवढं स्टील जास्त एक्सपॅन्शन कॉन्ट्रॅक्ट तिथे क्रॅक होईल, आणि ह्याचा रिएन्फोर्समेंट म्हणून आपण उपयोग करतच नाही होत. ह्याचा फक्त आकार देण्यापुरते लक्षात ठेवायचं. आकार जो पाहिजे तो देण्यापुरतं फक्त स्टील स्केलेटन आहे. आता याचं स्पेसिंग किती पाहिजे, 200 बाय 200, 300 बाय 300, 500 बाय 500 आपण ठरवायचं. ज्याप्रमाणे वॉलिंग पाहिजे आहे त्याला काही क्लोजर नको आहे, पण समजा ती स्लॅब असेल तर त्याला क्लोजर लागेल, ते आपण ठरवू शकतो. पुढे डिझाईनच्या ॲस्पेक्टमध्ये ते कव्हर होतं. तर हे बार स्केलेटन हे फक्त आकार देण्यापुरते लक्षात ठेवायचं. त्याचा व्हॉल्यूम फ्रॅक्शन ऑफ स्टील, त्याचा बॉन्ड हा कन्सिडर केला जात नाही डिझाईनमध्ये. पुढे आपण ज्यावेळेला ॲडव्हान्स डिझाईन त्यावेळेला करतो, पण आत्ता करत नाही. नंतर त्याला हे वेल्डमेज बांधलेलं आहे. हे वेल्डमेज त्याच्या वायरचा जो डायमीटर असतो त्याला गेज म्हणतात, वायर गेज म्हणतात. म्हणजे ते 10 असतं, 12 असतं, 14 असतं, 16 असतं, 18 असतं. हे जर का 10 गेज असेल तर त्याचा अर्थ त्याचा डायमीटर 3.15 एवढा mm असतो. हे जर का 12 असेल तर 2.5 mm. म्हणजे ते गेज म्हटलं की त्याचा डायमीटर वायरचा मिळतो आपल्याला. मग आता हे वेल्डमेज प्रिस्क्राईब करताना कसं करतात, मार्केटमध्ये कसं मिळतं की हे 4 इंच बाय 4 इंच बाय 10 गेज दोन्ही डायरेक्शन. आता वेल्डिंग करताना काही बार ह्या डायरेक्शनचे एका गेजचे असं, ह्या गेजचे वेगळ्या असं पण असू शकतं, पण जनरली एकाच गेजचे बार सगळीकडे वापरतात. तर मोठा ॲडव्हान्टेज बघा याच्यामध्ये की दोन्ही डायरेक्शनला सारखी रिएन्फोर्समेंट आहे. इकडे जे स्टील आहे तेच इकडे आहे. RCCमध्ये करताना मिळत नसेल, स्लॅबमध्ये आपण लॉन्जिट्युडल स्टील घालतो, ट्रान्सफर स्टील घालतो. ट्रान्सफर डायरेक्शनला स्ट्रेंथ नसते तेवढी, लॉन्जिट्युडल डायरेक्शनला डिझाईन करतो. तिथं दोन्ही डायरेक्शनला वेगवेगळ्या स्ट्रेंथ असतात, तसं इथं असत नाही. तिथं दोन्ही डायरेक्शनला सारखी स्ट्रेंथ आहे, हा मोठा ॲडव्हान्टेज आहे. दुसरं, हे वेल्डमेज जे आहे हे मार्केटमध्ये रेग्युलर विकत मिळतं. इथं असं वेल्डिंग केलं असतं, सरांचं फ्युजन वेल्डिंग करून हे बनवलेलं असतं. वायर्स अंथरलेले असतात फॅक्टरीमध्ये, दोन्ही डायरेक्शनला इलेक्ट्रिक सप्लाय देतात. त्यामुळे आपोआप जिथे जे कॉन्टॅक्ट येते ते फ्युजन होतं आणि वेल्डिंग होतं. अशा पद्धतीने हे वेल्डमेज तयार होतं. याचे निर्णय सायझेस अवेलेबल आहेत, 6 इंच बाय 6 इंचापर्यंत. निर्णय गेजेस अवेलेबल आहेत, 1 इंच 1 इंच 2 इंच 2 इंच याच्यापर्यंत. ओपनिंग सायझेस, स्पेसिंग असं सगळं बदलू शकतं. ते हे मार्केटमध्ये अवेलेबल असलेली गोष्ट आहे. हे आपण ह्याला घट्ट बांधतो किंवा फार वेगळा आपला आकार असेल त्याला वेल्ड पण करता येतं. हे वेल्डमेज याला वेल्ड करून पण आकार पुढे देता येतो. जर फार कॉम्प्लिकेटेड शेप असेल तो असा बेंड करून बांधायच्या वेळी वेल्ड पण करू शकतो. आणि तिसरी जी जाळी, कोंबडा जाळी म्हणतो ना, चिकन मेश. जनरली ही मेश असते, ही 2 प्रकारात अवेलेबल असते. एक स्क्वेअर वोव्हन मेश असते, म्हणजे वायर्स अशा एकमेकात अशा करून अशा गुंतवलेल्या असतात. वोव्हन मेश एक डायरेक्शनला असेल, दुसऱ्या डायरेक्शनला असेल, त्या स्क्वेअर असतात. त्याची ओपनिंग त्याच्या वेलमेशसारखी याची ओपनिंग स्क्वेअर असते. ही दुसरी जी पद्धत आहे ती अशी ही वायर इकडून अशी गुंडवून इकडून अशी आणली, म्हणजे वोव्हन आहे, पण हे विव्हिंग आहे, नुसतं असं नाही आहे, त्याच्यात पिळा घालून विव्हिंग केलं आहे त्याला. ह्याला वोव्हन मेश म्हणतात आणि याचे हेक्झॅगॉन्स आहेत, हेक्झॅगॉनल फॉर्म झाले आहेत. आता आम्ही प्रिफर करतो ही चिकन मेश प्रिफर करतो. त्याचं कारण असं आहे की आम्हाला ताणून बांधायचं आहे. असं ताणून जेव्हा बांधतात तेव्हा मला ताणलेलीवर याचा आकार मला करता येतो. हा मोठा ॲडव्हान्टेज आहे चिकन मेशचा. स्क्वेअर मेशमध्ये जर मी ताणायला गेलो ना तर वायरचे पिसेस बाहेर मोठे निघून असतात. नुसते एक इथं कसं आहे, एकमेकात गुंतवलेले असल्यामुळे असं जे ओढलं मी दोन्ही डायरेक्शनला तर ते घट्ट बसवतं. कामामध्ये चिकन मेश प्रिफर करतो. इतर लोक काम करताना काही जण एक्सपांडेड मेटेरियल पण वापरतात किंवा स्क्वेअर मेश पण वापरतात, स्क्वेअर वेल्डेड फाईन वायर मेश पण वापरतात. तर आम्ही हे प्रिफर करतो कारण आम्हाला ताणून घट्ट बसवायचं आहे, ही रिक्वायरमेंट आहे. आता ह्या स्केलेटनवरती वेल्डमेश ज्याला आपण बांधलं आहे त्याला आम्ही चिकन मेश घेतो आणि मी असे अडकून जनरली कसं असतं या वेल्डमेशला बाहेर प्रोजेक्शन आलेली असतात थोडीशी, त्याला अशी अडकून घेतो इकडं आणि इकडे अशी ताणून घेऊन अशी मांडतो. ती ताणताना काय होतं, तुम्ही पकडीने आणू शकता की असे हुक असतात बघा, मी साईटवर मी असा कान काढलेला असा बार असतो, तो त्याच्यात घालायचा आणि ओढायचा असा. त्या स्क्रूड्रायव्हर दोन घ्यायचे असे ताणायचे की हे ताणलं जातं. मग लगेच त्याला बाइंडिंग वायरनी त्याला म्हणजे ते टाका घालणं, म्हणजे असं हा मोठी बाइंडिंग वायर एवढी लागत नाही, असं घालायचं. पकड घ्यायची अशी, त्याला गाठ घातली आणि मग पकडीने त्याला असं टाईट करायचं. हा टाका बसला, हा पक्का टाका बसला पाहिजे, हे टाका घालणं म्हणतात. आणि असं ताणून घेऊन असं बांधत गेलो की चिकन मेश, 1 थर बांधायचा, 2 थर बांधायचं, जसं डिझाईन असेल त्याप्रमाणे लेयर्स बदलले जातात. ही बांधायची पद्धत झाली. आणि यातली मुख्यतः जे ट्रिक याची आहे मुख्यतः की हीच आहे की ताणून बांधणं चिकन मेश आणि वेल्डमेश हे अत्यंत महत्त्वाचं. आमचे काय करतो, 2 मेसन असतात त्यांना आम्ही पत्रे दिलेले असतात, पॉलिश पत्रे असतात ना, रंगरी वापरतात पॉलिश पत्रे. त्या पॉलिश पत्र्यावरती मॉर्टर घट्ट करून घेतो आणि ऑटोमॅटिकली आपले दाबून मॉर्टर दिलेलं आहे. ते म्हटलं की त्याला भिंत तयार झाली, कन्स्ट्रक्शन झाली, भिंत तयार झाली. त्या पद्धतीने कुठलंही स्ट्रक्चर बांधायचं इतकं सोपं आहे. आता ह्याच्यामध्ये बॉन्ड वाढवल्यामुळे जी स्ट्रेंथ वाढते त्यातून आपल्याला एक मटेरियल मिळालं की त्याची कॉम्प्रेशन स्ट्रेंथ खूप आहे. आता इथे बघा, मॉर्टर घातलं की हातात घट्ट गोळा वगैरे घातलं, इट इज कम हार्डली 1 ते 1.5 इंच. आता ह्या मटेरियलचा मोठा ॲडव्हान्टेज काय झाला, त्याच्या प्रॉपर्टीज त्याच्या डेव्हलप झाले बघा. त्याचा बॉन्ड वाढला म्हणजे कॉन्टॅक्ट एरिया वाढला, कॉन्टॅक्ट एरिया वाढल्यामुळे टेन्साईल स्ट्रेंथ वाढली. दुसरं काय झालं, या जाळ्या आणि मॉर्टर म्हणजे एकमेकांना फक्त घेऊ शकतो.
Now this is another entrance gate of a zoo, and you will see in this zoo the entrance is very similar, or it indicates that we are entering a zoo. And this component, this is an organic shape, and this is made of ferrocement. Now this is a typical house, and this can be assembled. Actually all these components are precast ferrocement components. The walls, the roofs, they are the precast components. We have just to assemble within 1 or 2 hours. These components are brought on the site. You have to assemble these components, and that's it. And within a day you can at least assemble 3 to 4 houses like this. When rehabilitation in certain cases flood affected area or earthquake affected area, we need immediate shelters. In that case, such precast ferrocement components can be assembled to make houses, and people can be shifted immediately here. You can always dismantle these buildings very easily, and they can be transported and stocked wherever you want. So this is the beauty of ferrocement, because they are lightweight components, but they are very strong components. Now this is a typical spherical shape. If we can imagine that if I want to construct such a sphere using RCC, so to construct the centering plates and formwork for the sphere, then casting the concrete in that, so it becomes very difficult. But if you consider ferrocement construction of this sphere, it is very, you have to weld the skeleton first, make the shape of the sphere, and just mortar it. After mortaring, just finish it and you get the sphere. Because this is a sphere, that is an atom, that is for garden or landscaping purpose. If at all such spherical water tank is to be designed, then we have to design it, we have to consider the loads, we have to consider the pressure of water in that, and we have to design the beams supporting it. So there it is possible. Whenever the landscaping atoms are there, which are very much attracted by the architects and landscaping persons, they want ferrocement there because it is a lightweight and it can be built very easy. Concept of folded plate supported on one side only, and this is called the ferrocement. Inside you get 6 mm, 8 mm bars, square mesh, welded mesh, and the chicken mesh or the hexagonal wire mesh. It is mortared by the cement mortar 1:3. So that is how the finished ferrocement staircase can be made. This is one more staircase. We built it at Katraj near Pune. There is one farmhouse or center for yoga. In that this staircase, you can see it has a peculiarity that in plan also it is curved, in elevation also it is curved. So three-dimensionally curved staircase. It is very difficult for the RCC person to design the centering plates, design the formwork and the casting of this cement concrete. So we decided to construct it in ferrocement. Initially, we inquired the RCC person what will be the estimate, and we built this staircase in 35,000. So we could save the money as well as we could save the time also. So that's how, in some cases, definitely ferrocement saves time, ferrocement saves money. So we can say architects and engineers, they love ferrocement. Just see the persons are coming down using this staircase. The supports, whatever you see, they are the temporary supports. They are removed afterwards. As you see, the hurricane speed is 483 km per hour, and that's how the aerodynamic shapes are very popular in Florida also, Indonesia, Bali. Seashore projects, they normally use aerodynamic shapes. Now this is a peculiar photograph. I will just show you the application of ferrocement. This is the Association of Women in Orissa. What they do, they make the skeletons of the boats like this. You see in this photo. This is the skeleton of the boat. 6 mm, 8 mm bars. They are covered with the square meshes and hexagonal chicken meshes, 3 layers. Once the skeleton is formed, you have to just mortar it. So this all business is done by the Association of Women, and these boats are sold there. So this is a sort of thing that people are doing on the seashore. This is one of the application. Actually, boat building is the main purpose of this ferrocement. Ferrocement was invented in 1842. That time, first boat was built using ferrocement. Now this is another application which is in Belgrade. This is the sports complex building actually. This is a semicircular, and you see that these are the supporting circular supports. These are the circular supports which are going to support the ferrocement components. In this photo, you will see the ferrocement tray-like structures. These are the precast trays which are kept one above the other on the supporting structure, and the joints are filled with the help of cement mortar. After filling the joints, you just remove the supports and you will get the building like this. After finishing the building and coloring it, you can use it for any purpose. This building is used as a sports complex. So this application of ferrocement in precast forms. This is one of the building which is self-sustained building, where you see the solar panels are fitted on the left hand side, and the thickness of the walls and thickness of the canopies you can observe. This is the plan of that building, and these are the panels. You see the canopy or the small porch where the thickness of the ferrocement is very minimum, say 45 to 50 millimeter after finishing it. This is the inside of that building, and you see the swimming pool is also constructed using ferrocement. Now yes, this is the different application of ferrocement. Roofing or space structures. In case of roofing, so you will always see many domes, shells are used by the architects to design the buildings. In case of mosques, typical shapes. In Gurudwara also you get typical shapes. In Hindu temples you get typical shapes of the shikhar or kalash, what we call as. And these structures, if we construct in using RCC, they definitely become costlier. But in ferrocement, it saves time, it saves money also, because ferrocement does not require any centering plate, or ferrocement does not require any formwork or typical formwork. This is just a skeleton, and skeleton works as a formwork. So that's how we can save money. So this is a typical shape of the mosque in Palembang. This was constructed in South Sumatra in 1985. Now see another mosque which was also constructed in 1985. Then 1983 structure, Lampung. Now this is 1984 structure in Jakarta. This is the entrance gate of a zoo. The two typical side-by-side structures, they look like birds, and that's why people are attracted to this. This is hollow inside. You can see the glass windows. The wall thickness is about 40 to 45 millimeter. Yeah, this is the typical structure which is very much liked by the architects. This is called as the hyperbolic paraboloid, or in short we can call it as a hyper structure. But this is a typical curve made from the parabola, and if you want to construct it using RCC or any other material, the accuracy is very important for the architects, and that's why constructing it in RCC is possible, but to design the centering, casting it with the concrete is difficult. So this is constructed using ferrocement. You see the accuracy of this. Whenever you want to construct such curves, you go for the ferrocement. This gives very accurate profile of any curve, say paraboloid or any such curve which is designed by the architect. So architects definitely prefer such structures. This was constructed in 1979. Now in Sri Lanka also, you see, on the seashore, these houses are very popular. These are the domes, and these are ferrocement domes. Laymen are also used to build such houses because these are the aerodynamic shapes. Lot of winds they have to face, and as such, they just have spherical shape, ferrocement meshes and mortars, and they can construct the ferrocement dome houses. If you see the inside of these houses, they are very attractively planned. Sometimes they have two floors, one above the other inside the dome. They have 2 bedrooms. It has got a very good ventilation also, as you see. Lighting effect is also good. So such dome houses can be constructed just like they are popular in Sri Lanka. This is a typical application in Bangladesh. They call it as reservoir or horizontal wire reinforcement is used. Vertical wire reinforcement is used. Then meshes are used, and they just use cement mortar 1:2, 1:3. This is a big size water tank, you can say. On the top it is open where water can be filled inside, and some taps can be used to draw out the water. These are some of the sculptures. Yes, ferrocement can be used for sculptures. These are hollow inside, and you get good shapes out of that. It is very easy to repair and very easy to give different shapes out of that. In Texas, in United States of America, 1973, House of Century was built. In 1981, because of some big storm and hurricane, everything was washed out except the skin of this building, because the skin of this building is built in ferrocement. So except that ferrocement walling, everything was washed away. Afterwards, they reconstructed this building, and this is the entertainment building. This is also called as Ant Farm. One video is available on YouTube. You can search such videos. So this was constructed in 1973 and again reconstructed in 1985. So these are the different shapes of the buildings, or bus stops, or you can say troll in the garden, or some elevation of the building which indicate what is going inside, say processing, food processing or fruit processing industry. The fruit elevation is seen here. Then selling or juice stand or fruit dishes, it's possible using such shape. So such very good shapes can be given to the buildings, small buildings or shops with the help of ferro cement. Yeah, this is the bus stop, Musk Melon bus stop. Yes, looks very nice. This also looks very nice. This is the sit out inside or viewpoint outside. Yeah, this is in Western Japan. This is called as Tomato bus stop. Then Pitchoid, South Carolina. This is the juice stand or a small shop where something is sold, say oranges or juice like that. Yeah, this is a big building having a good shape. Then this is a water tank at Satara, just like I mentioned, spherical water tank, which is supported with the help of ferrocement structure only. This was recently constructed 2 years before at Satara. This is a very good structure. It's called as a mega cave center. You know, Dome Dam is there nearby, and besides the backwater of the Dome Dam, this resort is constructed. 7 such buildings are constructed using ferrocement. These are looking very nice. This is the photo while the construction was going on. This construction was done by one of our members, Nandakumar Jadhav. Yes, ferrocement can be applied for water retaining structures, just like reservoirs and water tanks. In field, you can use this structure in arch shape. Actually, this is a multiple arch dam which stores water. This dam is built near Hatnur, a village in Sangli district. This was built by one of our members, Mr. Subhash Patil. The height of this dam is 3 meters, and the water is allowed to overflow on the central 4 multiple arches. Water overflows on the 4 arches, and the side 2 arches, they act as abutments or they are non-overflow arches. One such book on multiple arch dam is being published by Ferrocement Society. You can go through that book also, and you can construct small such check dams just to conserve water in villages, because there is a need now that water has to be conserved. Wherever you see excess water which is flowing to the rivers or which is flowing to the sea, we have to tap it, we have to check it, and we have to let it percolate in the grounds so that the adjacent villages or adjacent lands in the villages, they are recharged with the groundwater, and we get the wells recharged, and you can use the wells for irrigating the farms. So that's how such small check dams, they are definitely useful. This is a typical paper published in last FS 2019, that the paper was submitted by a person from Greece. So he built a very, very big ferrocement canopy at Stavros Niarchos Foundation Cultural Center in Athens in Greece. So this is a typical ferrocement application. Yeah, this is a small temple. Architect has designed it very nicely, and you see the walls, they are all ferrocement. The roof is also ferrocement. It's just like a gazebo temple. And in Satara, there is a housing complex called Raj Vastu. You see such temple is built there. This is built by our member, Mr. Sachin Lele. This is the basic application of ferrocement. Pontoons. ferrocement is a material which is very, very popular for boats. In Konkan also, or if you go to Pen area, you see the boat building activities there. In Sri Lanka, in Singapore also, you see ferrocement boats are there. In Orissa, you see the ferrocement boats. So this is a pontoon where you see the platform also. This is built using ferrocement. This is a typical application of ventilation roof. On the roof, you want to exhale the hot air, but this is not a moving, this is a static type arrangement. Fins are there in circular shape, diameter 10 feet, height say 4 feet. Such type of ventilator rooftop ferrocement structure is built by Mr. Kulkarni near Pune. Yeah, this is Paranzape schemes, which is called as woodlands near Kothrut. In that, this is a swimming pool having a typical shape. In Marathi, we call it kilvar shape. So that type of shape is there. Yeah, pyramidal slabs can be built with ferrocement. So this is a typical pyramidal slab near Pune in a housing complex. This has got thickness say 50 millimeter only, but you can imagine how it is not sagging in spite of such a large span. If you see from the bottom, it has got stiffeners or ribs, and because of the stiffeners and ribs, the slab cannot sag because it is well supported or self-supported with the ferrocement stiffeners or ferrocement ribs. So that's why whenever we want to build such large horizontal slabs or sloping slabs or curved slabs, necessarily we give or we provide, we design ribs or stiffeners. So that is very essential for the ferrocement large structures. Yeah, I will just show you a typical nala enclosing structure. This is a very, very big pipe which is built in Pune, say 20 years before. This was a nala behind the Dinanath Mangeshkar Hospital in say Erandwane area, and this nala was creating much nuisance. The builder was in trouble because the flats were not sold because of such dirty nala. So to provide such a big pipe to enclose such a nala was quite difficult because such precast pipes, RCC pipes, Hume pipes are not available. What we decided to construct ferrocement large pipe on the site itself, and that was designed by Dr. Divekar and constructed also. Corporation accepted this. You see the typical shape of this great pipe. On the bottom, it has got a trapezoidal channel slope because whenever the water storm or water discharge is limited, it will flow through that trapezoidal section. Whenever a rainstorm comes or rainwater comes in monsoon area, in that case, water level increases, and it is the larger area or larger width of the channel is provided by the side horizontal berms, and all this pipe and trapezoid is enclosed with half round shell, and this is all mortared afterwards, and the entire nala of length 700 feet was totally enclosed with ferrocement pipe. So that was the beauty. We just see construction is going on, temporary supports of the bars is given. The person sitting there is just tightening the meshes, hexagonal mesh. After that, this was all mortared with the help of 1:3 cement mortar, and the finished pipe from the above was seen like this. A photo came in Times of India also saying that anaconda appeared in Pune. So that was the appreciation given to the ferrocement pipe, and that was the only big pipe which is built in ferrocement in India. This is the largest pipe in India. Now we see one more application of irrigation canals. In many patches, you see the canals have large amount of leakage. Whenever the canal passes through bank work, if the adjacent soils are pervious, the canal leaks, and the farms or the farmers are very much annoyed that because of this leakage, their lands are damaged. So what to do? In that case, the RCC lining is a solution, no doubt is there. But RCC lining has life not more than 20 years. It damages, it cracks, and still it percolates. So for water tightness or waterproof canal, we have found ferrocement lining as a solution. This we tried in Nashik district, in Kalwan Taluka, on Pune project. We have selected 100 meters heavily leaking patch, and we tried this ferrocement lining. This is a one-piece lining. There is no joint, and after constructing such lining, we found that absolutely the leakage came to zero. The farmers were very happy that there was no leakage, and this was constructed in 2014. Now 6 years after construction, we just found that still the lining has no damage. It is still working and still giving service for water tightness of the canal. More than that, it provided less N value, that is the rugosity coefficient, and that's why the canal became efficient. It could pass more discharge, friction was less. That is the added advantage of ferrocement lining. A book is being published on ferrocement canal lining, and that will be published in next month. You can get a copy of that. In that, how parabolic sections are designed, how ferrocement lining is very much useful for canals, that is written there. So this book is very much essential for engineers who are going to work in irrigation, or working engineers who are working in irrigation departments. So these are our conferences. Mr. Pama, he's from Philippines. He visited India, and Dr. Divekar is talking with him. That was in 2015. And yeah, this is the group discussion on standardization problem of ferrocement. Ferrocement technology or ferrocement material is being standardized now. Bureau of Indian Standards, it is CED2 committee, and the meetings are going on. The draft standard is already prepared. It's under discussion of the panel. This is the photo of 2017 convention, where you see Mr. Jose Kurian, who is the head of BIS, who attended this convention in Kerala, and we had a joint common group discussion on standardization. Ferrocement Society publishes news bulletins every 2 months. You get world news, compilation of different projects which are going on ferrocement, latest development. Yeah, the different conventions that were organized by Ferrocement Society. We have got proceedings, and every book has got about 35 good quality technical papers which are received from India and abroad also. And these books are available. One can have such books in their library for further studies. Yeah, Ferrocement Society has already devised a ferrocement code which is called as FS code for practice. This is for walling. If you want to construct a wall, so this is based on the Indian standard code with sand, cement, Indian standards, and the construction methodology. You can construct a wall using this FS code. because Indian standard code is yet to come for wallings. But the Indian standard code for water tanks is already available, and up to 10,000 liters of water tank can be constructed using the Indian standard code. These are the two good books, and we can say the first of its kind, the book on design of ferrocement has already published, and that is written by Dr. B.N. Divekar. Dr. B.N. Divekar has got 35 years experience. Not only design experience, he has got a practical experience in ferrocement. First, in 8 years before, this book is published, Ferrocement Technology, which is a construction manual. This is useful to have general idea about the ferrocement and how to construct it. And the second book, Design of Ferrocrete Structures, for those who want to design the ferrocrete or ferrocement structures. Ferrocrete and ferrocement is one and the same. These are the two names of the same technology, and one can design different shapes, different dams, domes, shells, houses by using this Design of Ferrocrete Structures book. So these two books are available now. In Pune, we have established India Ferrocement Information Center. Here in Information Center, we have got all the journals of the world regarding ferrocement. They are available here. All the books are available. If some student wants to undergo post-graduation, or he wants to have some research, he wants to do some PhD on this ferrocement subject, we have got different topics of research to guide them, and we also have a very rich library here in Pune. So friends, you can become member of the Ferrocement Society, you can use these facilities, and you can go ahead. Recently, this is the development, Government of Maharashtra has published a very good handbook on ferrocement technology. This is for government engineers, civil engineers, PWD, irrigation, or say water supply engineers. They can use this handbook, which is ferrocement application for government works, as well as this can be used by private engineers also. Estimation and typical applications, rate analysis, everything is given in this book. This book is available freely on the website of the Government of Maharashtra Water Resources Department, as well as you can download this book from Ferrocement Society's website. So ferrocement has already entered in universities. You see, Savitribai Phule Pune University has already introduced full syllabus for 100 marks. And that is optional or elective subject. Then Symbiosis and Namala University and various universities, they are using this syllabus. So different publications are available with that already I introduced to you. Now there is a need to develop floating structures using ferrocement also, and recently we have given one training workshop to L&T at Chennai. So they wish to build floating structures for resorts, or these floating structures can be used to install solar panels. In Maharashtra also, or in all over India, we have got large reservoirs, and because of the sunshine, water gets evaporated. So if we construct such floating structures, and if we install solar panels on such structures, this can be used to generate the solar power also. And the second effect is that because of such solar panels, the evaporation rate of the water will be reduced. In arid areas in Maharashtra also, we have got a typical problem of evaporation of water from the reservoirs. Much water is lost because of the evaporation. So such floating structures will definitely be useful for us. So friends, you can become member of Ferrocement Society also, and Ferrocement is your friend. It is a friend of architect also. It is a friend of engineers also. So that's how we just dream and we can construct with the Ferrocement. So whenever you come across some curved shapes, definitely you think of Ferrocement, and that will save your time, that will save your money also. And this is very much useful for engineers and architects. So that's how I'm very much thankful to your institute. Thank you very much.
चव्हाण सर vote of thanks करा. चव्हाण सर अनम्यूट करा तुम्ही आधी स्वतःला. म्यूट आहेत तुम्ही. चव्हाण सर आपल्याला करता येतं का?
Hello.
हा बोला.
Good morning to all. On behalf of Department of Civil Engineering, AISSMS College of Engineering Pune, I take this opportunity to propose vote of thanks. I thank today's speaker, Engineer Chandramohan Hangekar sir, President Ferrocement Society of India. We are really enlightened with your knowledge and presence, sir. We are thankful to our management for their motivation. I would like to thank our principal, Dr. D.S. Bormane sir, for his support. A special thanks to our HOD, Dr. U.R. Avari sir, today's program convener, Dr. S.R. Parekar sir, organizing committee, teaching and non-teaching staff, students and participants. With this, I declare the end of the program. Thank you.
So I declare this program is over. Thank you.
Thank you, sir.